So we are back. We are using a Zoom, whatever that is using, that is taking 40 minutes max. So that is why it went off. Now let's continue so that we don't waste a lot of time. Just a minute. Okay, so I hope that you're able to see the screen that I've shared there. So it's just we are continuing with where we were. So we were talking about dependent and independent variables. A variable is a concept that can take up on a quantitative value or even a qualitative value. The general and the best way to describe a variable is basically a concept that can be measured. Okay, a variable is a concept that can be measured. Okay, it can be measured, it can be compared, it can be measured. It's like it is a concept that can actually be measured and considered for analysis. Okay, so for instance, if you're talking about crops, you can talk about things like um, the length of a maize crop, the length of a maize crop compared with the amount of rainfall it receives per year, or the length of a tree, or how long a tree grows compared to the amount of rain it receives per year. So length and amount of rain, those are two variables. Okay, so what is a dependent and an independent variable? A dependent and an independent variable is basically, a dependent variable is one that depends on another. In other words, it can change based on an independent variable. Okay, it can change. For instance, if you talk about the rate of somebody contracting other diseases based on the amount of let's go, no, that's a little bit far-fetched. Let's talk about just what we are talking about, the length of a tree. If it is a tree, we normally expect it to grow tall. The length of a tree depending on the amount of rainfall it receives per year. Okay, so the length of that tree is a dependent variable, and dependent variables, when you put them along the x and y, even you're putting them along the x and y grid, you will normally put them in the in the x-axis. Okay, in the wait, the month, amount of rainfall. So amount of rainfall. So amount of rainfall is an independent, it's a dependent variable, one that depends on another. So you're going to put the dependent variable in the x-axis, okay? In the x-axis. The way you could say, this is the amount of rainfall based on what month it is, the month, based on the month of the year. Rainfall against the month of the year, okay? So you're going to have month of the year, and then you're going to have rainfall ascending and descending, right? So you normally put the dependent variable in the x-axis, So the independent variable goes on the x-axis. In other words, the x-axis the independent variable goes to the x-axis. The x-axis is the horizontal one, and the dependent variable goes on the y-axis, the left one, the vertical one. Okay, so if you're talking about how much rain does a place receive in given months of the year, which is the dependent and which is the independent variable? Rain is the dependent variable because rain depends on the month. Okay, month does not depend on the rain. Rain depends on the month. So the rain is a dependent variable, so it's going to go to the y-axis. Okay, the dependent variable, the one that depends on the other, the vertical one. Okay, so that it can keep changing and all that. Yeah. And then the independent variable, which is month, goes to the x-axis, the horizontal one. So the independent variable is the one that depends. The dependent variable is the one that depends on another for it to change, meaning that when the independent variable changes, the dependent may also be expected to change. Okay. All right, so we go to extraneous variables. An extraneous variable is basically a variable that affects the dependent variable, but from outside. Are you together? An extraneous variable is an external variable that affects the dependent variable, but from outside. The dependent variable will be affected automatically by the independent variable. So if you're talking about the rain, the amount of rain in millimeters being affected by the month of the year, then the rain is the dependent variable. But the only thing it may not be the month only that affects the rain. There are very many other factors that can affect how much rain a place receives. For instance, the number of trees, or the amount of forestry in an area. The amount of forestry in an area may also affect how many. So the more you continue cutting trees, the more, if you are receiving 400 millimeters of rain, then you'll be receiving 300 in the same month. You cut trees. So extraneous variables are basically variables that affect dependent variables, but they are not within the scale of measurement. They are not the ones being measured. They are not the interest of the research, but they still affect that dependent variable. Okay, so if you're talking about rain versus month, our dependent is rain, our independent is month. But then there are other factors like the rate of forestry that normally affects rain, whether it's whichever month. The rate of forestry will affect the rain. Yeah. Also, there are some, there are other factors like factors that you cannot control. Factors that you cannot control, like the rise and fall of tides that are normally affected by the moon and such kind of things. Those are extraneous variables. And normally extraneous variables, if you are working with extraneous variables in a scientific lab, you normally place what you are measuring in a control room or in a control center, so that that particular thing that you are measuring may not be affected by the extraneous variables. Okay, so if you are measuring, that's why we normally put, okay, if you're measuring the amount of time it takes for a particular solid, like a metal like mercury, to burn and melt, right? Now, the amount of time will be affected by the amount of heat, but also it will be affected by what? By air. So if there is air, you may find that it may take a longer time. So that's why you'll find that most of the burning in a scientific room will be controlled in a burning control cube or burning control center, something like that. Okay. Please mute your mics. Samuel Bugwa, mute your mic. Or who is it? All right. So basically what I'm saying is an extraneous variable is a variable that affects the dependent variable, but it is not within the scale of measurement, or it is not the area of interest. It's not the one we're interested in, okay? because the one we're interested in is basically the what? The dependent and the independent. But the dependent can be affected by other variables. So those other variables that are not within our interest in the research are called extraneous variables. They affect the dependent variable. Then control. Control, this term is normally used in scientific researches. A control measure or a control is basically it's a measure that is used to minimize the influence or effects of extraneous variables. So that's what we have talked about when we are doing a research in a scientific lab. We are going to have what? We are going to have, you know, like, what do you call that? Where you burn things. Yeah? Where you burn things, a particular area which is, it is airtight. It is airtight and you actually burn things in the lab. It's called a burning cage or what. So basically that burning cage is a control measure that has been put so that whatever you're measuring in there may not be affected by other factors like wind, like temperature outside. Okay. Yeah. So controls is what you put in place. It's a measure you put in place to minimize the influence of an extraneous variable. Confounded relationship. Confounded relationship is when the dependent variable is not at all free from extraneous variables, and those extraneous variables cannot be controlled. All right? When the dependent variable is not free from the influence of extraneous variables, the relationship is said to be confounded. The relationship between the dependent and the independent variable is said to be confounded by an extraneous variable. So if you are doing a research, on, let's go back to the scientific researches. You're doing a research on how much time it takes to burn solid mercury into liquid, to melt solid mercury into liquid, right? So if there are things that come in play that you cannot actually control, then those things, if there are other factors, there are variables that affect the amount of time it takes to liquefy solid mercury. There are variables that take effect apart from the independent variable. Probably you could be having one independent variable like amount of heat. That could be the independent variable. Independent variable amount of heat, it can be 10 degrees Celsius. So if you say, if I put 400 degrees Celsius, then solid mercury takes 2 minutes to melt, or something like that. If I put 200 degrees Celsius, solid mercury takes 3.7 minutes to melt. All right. But there are other things that probably may suffice that dependent variable. What is a dependent variable? The time. Time is a dependent variable. It is the time taken by the solid mercury to melt is the dependent. Why? Because it depends on the amount of heat. But apart from amount of heat, there could be variables like air. If during that research, air is something you cannot control, all right? Air is something you cannot control, then, or even room pressure. Room pressure is something you cannot control. Those kind of factors where those kind of variables which you cannot actually control, they will definitely influence the dependent variable. You cannot really control them. They make the relationship between the dependent variable and the independent to be what is called a confounded relationship. All right, a confounded relationship. Then what is a research hypothesis? A research hypothesis is an assumption that you make before the research. And therefore, what is the role of an assumption? That assumption, a hypothesis, that assumption, the role of that assumption is to lead you into finding correct answers for that research. That is what is called a research hypothesis. It's an assumption that you make, okay? A prediction that you make. It's a predictive statement. As you can read here, it's a predictive statement which are not objectively verified, meaning that it's a prediction. It's an assumption you have, but you have not tested that assumption to know whether it's true or false. right? But that assumption can be said to be true or false if the research is conducted. So why do we need a research hypothesis? And during your project, you're actually going to be taught how to write a research hypothesis, okay? A research hypothesis. And also at some point, I'm also going to teach you how to write a research proposal. So inside the research proposal, I'm going to teach you how to write a hypothesis, okay? A research hypothesis is a prediction, and it helps you to do the research geared in answering that particular assumption or proving that particular assumption. So for instance, you may be doing a research on online buying and selling, e-commerce, during the COVID-19 pandemic. How has the COVID-19 pandemic affected online buying and selling? Are people buying things and selling things more online or more physically during the COVID-19? No, so you can make you have not objectively verified, but it's a general prediction. You can actually make that because people are social distancing, the rate of e-commerce has gone higher. The rate of online buying and selling has gone higher during the COVID-19 pandemic. All right. So of course, COVID-19 pandemic is the independent variable, and the rate of e-commerce is the dependent variable. It has been affected by the COVID-19. So that is an assumption. The rate of e-commerce has gone high during COVID-19 because of physical distancing or social distancing. That is an assumption. It is very, very easy to say that that assumption is correct, but you know it is subjective. It is an assumption you've made, you as a researcher. You've not tested it. Okay, so when you go now to the research, if you are doing the research that has a subject title like the impact of COVID-19 pandemic on e-commerce. All right. So one of the research hypotheses will be COVID-19 pandemic has caused the rate of e-commerce and people to buy more online than physically due to social distancing and the fear of contracting the disease outside. Okay. Yeah, that is an assumption, and which can be true, but you know it has not been tested. That is now why you now go to do the research, collect data, so that now you can prove whether your assumption is true or false. So a research hypothesis is a predictive statement that is subjective, meaning it is not objective. It has not been tested. Okay. Number 6, experimental and non-experimental hypothesis testing. So when you are testing whether this assumption is true or not, you may use an experimental method or a non-experimental method. An experimental method is one where you are testing different variables. When you are testing an assumption, whether it is true or false, it can either be experimental or non-experimental. Now, experimental researches are where you're going to go out and compare different variables. You're going to write down different quantitative data. You try to adjust this particular data to see how it affects this particular data. You adjust this to see how it affects this. Just like in a scientific lab, you adjust amount of heat to see the amount of time it takes to liquefy solid mercury. You reduce the amount of heat and you increase the room pressure, the heat, you reduce the heat, increase the pressure, and see how the time is going to be affected. Basically, that is what we call an experimental research. All right. Experimental research is where you compare different values by changing different values to see how a certain value, which is a dependent variable, also changes. Okay. And non-experimental research is one where there's no comparison. This may describe kinds of research like descriptive research, where you just go to gather facts. Okay. You're not comparing anything, you're just gathering facts. Okay. That is non-experimental. Okay. Now, what are experimental and control groups? In a scientific lab, you may want to know, you will always have to have the two particular groups. A control group is one in an experimental hypothesis testing, like in a scientific lab, when a group is exposed to usual conditions, it is termed as a control group. For instance, in something like a lab, the usual conditions for mercury to melt in 2 minutes is to give it 400 degrees Celsius. Probably, I don't know. I'm just making an assumption here because we are not in a science class, so we don't have the time to prove whether that is false or true. Let's say if, for you to liquefy mercury, you need 400 degrees Celsius. Let's just say. So if that is a normal condition, 400 degrees Celsius is the one needed to liquefy mercury in 2 minutes or in 1 minute. Okay, so that is going to be the control group. All right, one that you are liquefying using 400 degrees Celsius. Then you're going to try and liquefy another using other different. So you are going to use another using 200 degrees Celsius. You're going to use another mercury pebble and liquefy it using 350 degrees Celsius. You're going to use another mercury pebble, turn heat to 600 degrees Celsius and see how it does and see how much time it takes to liquefy. Now, basically, all these others that are changing, you have changed the normal condition, the independent variable, you've changed it. Those are called experimental groups. But this one that you have put in a normal condition is called the control group. Now, the function of the control group is to verify the experimental groups. Okay, is to verify the experimental groups. Now, what is a treatment? A treatment. So the different conditions under which experimental and control groups are put are usually referred to treatments. So if 400 degrees Celsius is for control, and then there you have other three that are being liquefied in other chambers, burning chambers, like 250. This one in chamber B is being burnt at 250 degrees Celsius. This one in chamber C is being burnt at 600 degrees. This one in chamber D is being burnt at 550 degrees Celsius. Then those different kinds of temperatures, you've subjected the same type of mercury pebble. Those different types of temperatures are called what? Treatments. Okay, treatments is the condition which the experimental and control groups are put under. Okay, treatments. How do you treat the particular thing you're testing? One mercury pebble, you've treated it under 400, which is normal. So that's a control group. Then another group, you have treated it under 600 degrees. Another group, you've treated it under 200. Another group under 400 degrees. So those kinds of different temperatures are called treatment. So treatment is basically the condition you place a group under, whether it's an experimental group or a control group. And what is an experiment? An experiment is a scientific, rigorous, and systematic process of examining a truth. It is a scientific, rigorous, and systematic. Scientific because it uses the rules of science, which is analysis, mathematical calculations, comparisons, all right? So scientific in nature. It is rigorous, meaning it is made up of activities, full of activities. Like if you put this mercury pebble in one chamber, another chamber, another chamber, and then you put on the heat and you begin comparing, begin reading the readings, taking the readings. It is rigorous. Those are activities you are doing. Okay, you take the readings, you write them, you watch as it burns, you take the readings, you write them, you record, you test, you do it again and again and again and again to verify whether there are changes, and you pick all those things, you find their mean or their mean, whatever, and then you find those things. So it is rigorous, meaning that you have to do over and over again. You don't do one experiment. You don't just do one experiment, you do different experiments for the same subject, okay? Because you need to see how those changes come up, and then you take note of those changes, and you find the middle ground. So it is rigorous. It's scientific, number one, it is rigorous, and it is also systematic. In other words, there's a process to do it. You don't just go to the lab, na unaanza kuwasha moto. That is not systematic. You go, you pick a Bunsen burner, you pick test tubes, you pick whatever, you pick this, You mix whatever you want to mix, you put them in the burning chamber, you connect your computer. If it's a computer you're taking to take record, you're using to take records, you switch on your computer, you have your table, you create a table. If it's a Word table, if it's an Excel table, you indicate temperature, time, control group B, control group A, experimental group B, experimental C, experimental D, and then you begin to note down recordings as you read. Systematic. There's a procedure. That is why even when you are going to the lab when you're in high school, you are told not to do any experiment without the help of the teacher or the lab assistant, right? Because it's systematic. There is an order to it. You don't just go and begin lighting fires. You may light yourself in the process. Yeah. So it is scientific. It is rigorous. There are activities you do. You can even keep repeating it. It's rigorous, and it's also systematic. And what is the idea behind an experiment is to test or examine a truth. So if it is you're doing it can be an experiment on how much time does it take, how much temperature does it take to liquefy mercury. Yeah, that is examining a certain truth. All right. So what is an experimental unit? An experimental unit now, it's a predetermined plot or block where different treatments are used. Okay. So do you remember experimental and control groups? Yeah. So those groups can also be called experimental units because each of them have been subjected under a different treatment. Okay, so an experimental unit is a block, or it's a group that has been subjected to a particular treatment. Okay, it's a unit. So you can call them units, experimental units, and one unit will be a control group, and the other units will be experimental groups. But all of them, they are experimental units. Why? Because they are blocks within which experiments are happening. Okay, and each of them have a different particular treatment. All right. Okay, so that is where we are. So any question before we continue? Any question before we continue? Now, there are different kinds of research designs that are normally used. There are different kinds of research designs that are normally used. So I'm going to share with you the research designs. So I'm going to give you, and I'm going to tell you to, I'm going to share a screen here, and then I'm going to allow you, I can see our 10 minutes, whatever is actually running out. Actually have less than 10 minutes, so that, and this session will be over. But well, let me share. And then I'm going to create yet another session, because after all, that is where we are here to learn. And all right, I'm going to share this. I'm going to share this screen. Types of research design. So, all right. Types of research design, there we go. There are different kinds of research designs based on the type of research that you're conducting. Okay, there's action research design, case study design, causal design, cohort design, cross-sectional design, descriptive design, experimental design, exploratory design, historical design, longitudinal design, observational design, philosophical, and sequential design. I think I can number these so that they can know how many they are. So these are 13 kinds of designs. Now, these designs, they are, I should say this very important thing, they are all based on the type of research, based on the type of research in question, based on the type of research question. Now, our session is ending very soon. Can see we have already elapsed our time. We're actually remaining with 6 minutes. Maybe I can actually mention, and then I'm going also to create another session so that we can finish up this, so that we don't have to create another class for research design. We finish it up today. So I'm just going to give a brief overview. Every kind of these designs are named according to the kind of research, right? So do you remember all those kinds of research? Qualitative research, quantitative research, analytical research, descriptive research, those kinds of things. So they are named according or closely to the types of researches. Okay. So if we are talking about something like causal design. Causal design is a design that deals with a research. A causal design is a research design for a research where you're going to go and investigate for a cause of something, like what causes married people to divorce. You are going, basically your research is basically to discuss or to find out causes, a cause or causes of particular things, okay, causes. Cohort design. Cohort is where you're going to be researching on a particular group of people. Like the way we talk about 2019, 2020 cohort. When you are graduating, you'll hear that very much. The cohort of 2019, 2020. We are just saying these are a group of, they are all of them, they are similar in that they are all ZTech University students, but we call them a cohort because they are a specific group of the whole ZTech University group that have one particular thing in characteristics, and that is that they are graduating in the same academic year. Okay, so like you belong to each cohort, belong to 2019, 2020, right? The academic year 20, you're going to graduate 2019, 2020. That is, if you don't, if you graduate, yeah, I believe you know what I'm saying, yeah. So cohort is basically, if I'm going to be making a research on a particular group of people, specific group of people, then we call it a cohort. What that research is, a cohort research, and basically the research design is called a cohort design. That's basically the idea, okay. Cross-sectional design, you're going to discuss. Descriptive design is when you are going to describe how phenomenon work. Yeah, describe like how architecture works, like how a city manages its drainage system, how shops manage their security, you know, descriptive things, okay. And normally descriptive is about hows and whys. Experimental design is when you are performing an experiment, scientific research, a scientific experiment. Exploratory design is when you are making exploration, for instance, astronomical or astronomical explorations, sea explorations. You know, those people that go with submarines and they go to research for things deep into the sea. Those are called exploratory researches. So when you're going to explore, the kind of design you write, you prepare for that kind of a research is an exploratory design, because your design is an exploratory research, okay? Or even it's you're going to explore the, you know, space or the Milky Way galaxy, yeah? So exploratory, astronomical explorations. Historical design is for researches that are historical in nature. For instance, you are discussing the history of a nation. Your research is based on the history of a certain community, the history of a certain religion, the history of e-commerce, right? You're doing IT, the history of programming. If you're doing a research on that, that's a historical research. So the research design document you are preparing is a historical design, just because what influences the kind of research is just the name of the research, the type of the research, okay? Longitudinal, we're going to discuss observational design, when if your research will be all about observing, some things, some phenomena, like people who take pictures for Nat Geo, yeah, their researches are observational, yeah. Or if you want to do an observation of how people move in different, how a particular street is normally populated in different times of the day, you'll put a camera somewhere, it stays there, and you just watch. That's observation. So it's an observational research. So the research design is also called an observational design. Philosophical design is when you are dealing with philosophical subjects. Okay, philosophical subjects are subjects that nobody has a conclusive remark. It can be researched over and over again. For instance, religious matters. That's a philosophical subject. Why? Because it involves people thinking about a matter, and there can never be a solution to it. For instance, if we are talking about what is the origin of God, yeah, everybody can talk about where God comes from, right? Things like that. Yeah, philosophical, meaning that we can study it. All right, everybody can actually study it, and everybody can discuss it the way they wish. Okay, and then we are going to also discuss sequential design. So which ones are we remaining with? Action, case study. Our time is actually out. And descriptive, and longitudinal, and sequential. So we're going to discuss that in the next session. All right. So let me create the next session. The one we are having is ending at right about now.